Hello everyone, I'm Parvez Mahbub, a master's student at Dalhousie University, Canada. I'm working with Dr. Masood Rahman. In this video, I'm going to show you our new deep learning-based debugging tool, Bugsplainer, which learns from thousands of bug fix commits. Bugsplainer can explain the bug in the source code and help you to fix it. It is a joint work by Dalhousie University, Canada and Metabobin Corporation, USA. Bugsplainer is developed as a web application so that you don't have to install anything on your local machine, and we handle the hassle. Simply browse the application from your favorite web browser and you are all set. You can find the URL of the website in the description of this video. Bugsplainer has 4 different components: the selection panel, the code editor, the explanation generator at the backend, and the explanation visualizer. Let's get to them one by one. The selection panel is what you see when you load the app. It contains a file input. You can select any Python file in your machine from there. Then it has 2 fields to input the line numbers of the buggy code segment. After that, you can select the underlying deep learning model to generate the explanations. We will get into that in a minute. Finally, you can click on the explain button to generate and show the explanations. Let's select a Python file. It is now loaded in a text editor with basic syntax highlighting. You can change the code here and generate explanations for the changed code as well. When we click on the explain button, an HTTP request is sent to the backend server. This request contains the whole source code, the selected line numbers, and the name of the deep learning model. The backend server first generates an abstract syntax tree from the source code and extracts the AST nodes within the selected line numbers. Then it converts these AST nodes into a sequence of tokens using our developed algorithm named deepSBT. Finally, the deep learning models take this token sequence as input and generates these explanations. These explanations are then shown in the explanation visualizer on the right. To better understand the usefulness of Bugsplainer, consider a use case scenario. Let's think about Alice. Alice is a software engineer and she is trying to scrape some data from GitHub. She wrote a Python script to do the scraping for her. However, she runs into a problem. Whenever she runs the script, after a while, it crashes. She tries some static analysis tools to detect the problem, for instance, PyFlakes. Unfortunately, it cannot detect the buggy code, let alone explain the code. Now let's say she used some cutting-edge bug localization techniques to find the location of the bug. Let's say the bug in the given script resides from line 131 to 134. However, they do not explain what the error in the code is or what should be fixed in the code. So even after knowing the location of the bug, Alice could not fix it. Okay, let's use Bugsplainer and see what happens. Here, I'm going to load the script into the app. Select the buggy code segment. I'm going to keep the model as Bugsplainer. And finally click on the explain button. Bugsplainer explains the buggy code as make rate limit response compliant. Having this explanation, Alice looks at her code again and realizes what is the problem. She is hitting 2 different GitHub REST APIs. In one of them, she is specifying that she wants the response in diff format. However, in the other, she does not say what the response type should be. Therefore, in a later phase, the code crashes due to the difference in these response types. After fixing this issue, the source code starts to run again. However, after running for a while, the code crashes again. Alice comes back to Bugsplainer again and sees that Bugsplainer provides different explainer models to get explanations for different aspects of the bug. This time, Alice selects Bugsplainer 220 million parameter model and again asks for an explanation. This time, Bugsplainer explains it as add token header to rate limited response. Alice looks at her code again and finds that she forgot to pass the authentication token to the first API call. Therefore, after a certain amount of time, GitHub stops responding to the requests and the script crashes. Alice fixed this error too, and now her script is working as expected. This way, Bugsplainer provides accurate and concise explanations that can help software engineers better understand and fix bugs.